This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, okgrow.com, and spacedojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. All right, so welcome to our second Crater Conf makeup session today. We are going to hear a talk from Jeremy Shimko. He's been working with Reaction Commerce, actually, and they've built a platform using Meteor and Docker. And, well, I'll let him explain it all. But welcome, Jeremy. Awesome to have you.
Thank you very much for having me. First off, I just want to thank you and everybody who came back today for the accommodating the schedule change and being able to come back for the makeup session. That's awesome. So thank you. Yeah. So there's a pretty wide range of topic to cover here, but I'm going to try and boil it down to like the minimum amount to kind of get people started. This is of course assuming a Meteor audience and that want to get started with Docker and want to kind of get an idea of what step one is. First, my slides work here. A little bit about myself. I'm a longtime freelancer, full stack Node JavaScript dork with a kind of long-time focus on DevOps. But before doing mostly Meteor Node stuff like I am now, I was freelancing more generalist and also an audio and video engineer. And the way that all kind of tied together was I worked for a production company or a variety of production companies doing a lot of live webcasting, actually, kind of ironically, like live conference webcasting. A little bit different format than this, actually, the in-person kind of conference type of thing, but that was kind of the core of my job description was going and doing the live production stuff, but also doing all of the web infrastructure for distributing the live video streaming. Kind of probably similar to probably the most recognizable name that does stuff like that now is livestream.com. They kind of specialize in that live event space. But for the last 3 or 4 years, I've been exclusively just web developer, and most of that has been almost entirely Meteor as well. Now, as of fairly recently, I am full-time at OngoWorks, and those are the folks that are responsible for Reaction Commerce. And most of my role over there is building LaunchDoc, which is the platform as a service that is being used to launch Dockerized versions of Reaction Commerce apps for customers. So, customer signs up and launches an app instance, and it essentially launches a Dockerized version of Reaction for them on our infrastructure. So not all that dissimilar to Galaxy, of course, just a little bit more customized for our use case. So the kind of the overview of what I hope to go through today and touch on a little bit of each of these items is just a high level of what Docker is and why a Meteor developer might actually care, what Docker Cloud is, little sidebar here is Tutum, about 2 weeks before my talk, or I'm sorry, 2 days before my talk was supposed to be last week, Tutum announced that they are discontinuing the platform in favor of Docker Cloud, which is, for those that don't know, Docker bought Tutum a few months back, and they are rebranding the Tutum platform as Docker Cloud. So a handful of things changed under the hood, but for the most part, it's the same app. So kind of a curveball at the last minute, but for the most part, to be fair, it's mostly logo changes and a couple of terminology changes, but the underlying functionality is all still there. Really common question I get for all of this stuff is, so it's like everything else in this space, there's an overwhelming amount of things to learn about it. With Docker, or even wider than that, DevOps in general, it's, they're whole different job descriptions all by themselves. So you could easily focus 100% of your time on that and never learn everything the same way you can with JavaScript. So one of the most common questions I get about this stuff is it actually going to be worth my time to learn the basics of this, to use this, and is it even feasible to accomplish much with a small amount of information? Because a lot of times that's not the case. Just skimming the surface and getting the basics doesn't really get you too far. But in the case of Docker and Meteor, you actually can surprisingly get by with just the basics, and that's kind of where Docker Cloud comes in. Is it kind of allows you to not have to understand a lot of the infrastructure side of things, and they take care of all of the orchestration, deploying Docker containers, across lots of servers, and they take a lot of the hard parts out, the DevOpsy parts out of it, and give you a nice interface to click around in to do that yourself. Yes, the next most common question is like, where do I even start with this stuff? There's so many bits to learn. Like, what's the important stuff to even begin? So that's kind of the main idea of this talk in the first place. Is just the basics, and just get to working deployed app. And then anything else after that is kind of optional, and you can expand on it as you desire. So obviously, the biggest question is, what is Docker? And probably the most common comparison I hear to Docker is to VMs. So most people know what most developers know what a virtual machine is. Think VirtualBox or something like that, or Vagrant, which can be using VirtualBox under the hood. But essentially, they're just images of an entire operating system, and you can reliably have a snapshot of an operating system in a moment in time, and transport that around. And it will reliably do the same thing no matter where you run it, because it's the whole operating system with everything in it. The difference with Docker, so the problem with that is it's the entire operating system. So it's huge. It's in the probably tens of gigabytes. So it's not very transportable. It's not a convenient unit to move around, and there's a lot of redundant stuff happening. So, for example, you have 3 different Meteor apps, and they're all on the same operating system. You don't need to have 3 full snapshots of that entire operating system, because the only thing that's different between those 3 apps are the apps themselves. So, kind of enter Docker. That's what that aims to be, is a snapshot of just the app, the app and its dependencies, and then you have a server that runs the Docker runtime, the Docker engine, and that becomes the base. Using the VM analogy, that becomes like the base VM, and then everything else runs on top of that. So all of those things that are common, shared across all of those apps, can share that common base without having to be transported with that app image. And probably one of the best spots to kind of get a. I was going to make a diagram for this, but it seemed like such a unnecessary thing to do because one already exists. Right on Docker's website, right at the top of their homepage there's a what is Docker, and this is pretty close to the top of that page. And this is essentially illustrating the point I was just making. On the left, you can see the guest OS blocks. Those are the entire operating system. So that's using Ubuntu as an example. Those are 3 full snapshots of the entire operating system, and they're identical. So it's pretty inefficient. And on the right, you see the Docker version of the same thing, where the common base ends at Docker. So all you need is a server running Docker, and any Docker container will run on it. Another kind of great analogy that's fairly similar to that I just heard somebody say the other day was it's like shipping containers, and of course that's where the Docker name comes from, is from boat shipping containers. But the point there, the analogy is that shipping containers are all a standardized size, and that would have been a great opportunity for a picture of shipping container. Sorry about that. So they're all a standardized size, and a boat that carries shipping containers does not care what's in those shipping containers. It could be clothing, it could be food, it could be whatever. Shipping containers have their own refrigeration sometimes. In the case of food, they have their own climate control. That's how bananas come from across the world in a shipping container. And that is kept at a very specific humidity and temperature, and anything outside of that shipping container, the boat doesn't care what's in there. And then another shipping container may have absolutely no climate control necessity, but both of those shipping containers are the exact same size, and they stack in the exact same way, and they will fit on any boat meant for those shipping containers. So that analogy boat is our so it doesn't care anywhere that has Docker. So that's kind of the idea there. So the big obvious gain there is of course if it works on one server, you can expect that it'll work identically on the other server. There are it's a very short list of exceptions to that statement. So yes, that's kind of Docker in a nutshell. The next most common question is, how do I tie this into Meteor? And it's actually a surprisingly short list of steps to just do the basics, to get a Meteor app inside a Docker container. And my couple of my favorite base images for Meteor are these guys. I just kind of recently started using Tupperware from Chris Wessels, and meteor.d, of course, is from Aranota, and it has been around and popular for quite some time. These are both pretty battle tested base containers. What does it mean to be a base container? So if you think about what the dependencies are of a Meteor app, obviously you have Node at a specific version. Obviously it's on a higher level than that. It's on a Linux machine. And then you might have a whole bunch of optional dependencies, Phantom.js and whatever. There's tons of other things that may be app specific that you might put in there. But at the very least, both of these will get pretty much any Meteor app up and running with a single line Docker file in the root of your project. So the other half of every Meteor app, every single Meteor app, is of course Mongo, and there's two ways you can go with that. So you can go the route that Galaxy does, and you use another provider for Mongo, and that of course splits up the responsibility across a couple different places, and obviously your Mongo instance should be different in a different place than your app is anyway, for performance reasons. So it kind of doesn't matter where it is, whether or not you put it in a container on another one of your servers, or you use Mongo as a service like Compose or MongoLab. For the purposes of this talk and the demo I'm going to do shortly, we are going to do a Dockerized version of that, and I'm going to tell you the couple of caveats you have to think of there. So there are a couple of images I like for that. Of course, there is the officially sanctioned Mongo Docker image, and then there is the one that I built, which has the main purpose of it is to run a replica set, to run 3 containers, 3 Mongo containers, ideally across 3 separate servers, but not required, and run them as a replica set. Excuse me. So kind of the caveat to Mongo in a container is that your data is in a container. So there are a handful of, that starts to work its way up, a slightly more advanced Docker usage, but kind of high level. You don't want to leave the data inside the container. You want your containers to be immutable. You want to be able to lose and start more containers, or swap them out if one fails. You never want anything to stay inside a container that you care about. So short answer is that's why hosting elsewhere with a Mongo as a service can be significantly easier, especially if you're new to Docker and managing persistent data in Docker. But there are other options. So for example, you can do data containers, which are just containers that are linked to a, in this case, a Mongo image. And all that container does is take the data, it's linked to the Mongo container, and the data from the Mongo container goes in there. And then you can swap out your Mongo container, and it'll, link back to that storage container when a new one comes back up. And that's one way to persist your data. The other is to to persist it on the host itself. So when you run a Mongo container on a server, you can persist that data in a directory on that host. That's probably a slightly simpler, easier to manage scenario, but because it starts to work its way into slightly more advanced, we're just going to keep it right in the container, kind of disposable Mongo for the sake of the demo. And of course, my phone rings. So what is Docker Cloud? And oh my God. And of course, the iPad's ringing. So Docker Cloud, up until last week, was Tutum. Tutum, to understand what Docker Cloud is, a little bit of history behind that is there was a company, Tutum, that was bought by Docker a few months ago. Is a platform that you could use to orchestrate Docker containers across any amount of servers. So you can use it to launch your own server, to launch your servers. You can use it to deploy your Docker containers to the servers. You can have container repos there, storing your container repos there, just like with Docker Hub, which sorry to step back a second. Docker Hub is basically GitHub for Docker containers. It's versioned containers and functions basically how you would expect it to if you are familiar with GitHub. So Tutum has their own private container repo, and they also will do all of the orchestration and server setup for you, and you can use it with any major cloud hosting provider, AWS, DigitalOcean, and Azure, or any of those, or custom, or I'm not sure what the term they use for it is, but basically, if you had your own server running in your own data center, you could also use that as well. But the cloud integrations are obviously a bit more feature rich because they're talking directly to the platform. So Tutum takes a lot of the pain out of managing container repos and server orchestration and container orchestration across the servers. All these things you can do with the standard Docker toolbox, which is actually what it's called. But if you want a slightly more managed point and click version of that, and you don't want to be in CLI for all of that, Tutum is kind of aiming to be that. So as I said, Docker bought them a few months ago, and it was unclear until last week when they made this surprise announcement that what they were going to do. It sounded like they were continuing on, but it wasn't clear if it was going to be the same product. But the short-ish story there is it is the same product. It just has a new logo and a kind of humorously not quite finished website. Which actually you won't find a link to on their website. They so they released they released this to current Tutum users last week, and said your account transfers over, but they're not really pushing it too hard on the main site. So you might not find it if you go looking for it. But know that it is cloud.docker.com. So easy enough URL to remember. So that's it for looking at static slides. I am now going to just walk through doing the very basics of setting an app up with Docker and Docker Cloud and getting it deployed and getting an automated redeployment when you push to your repo on GitHub. So let me just switch desktops here so you can actually see my correct desktop. Let's see. Okay. So what we have here is this is the Meteor.js app. This is literally the the Meteor create example to-dos. Yeah, you can ignore my M alias there for Meteor. So that this folder is the output of that. So because I already have some configs in there, I won't do it again. But let's go take a look and see what we have in here. So so nothing done to the app at all. The only things added are these couple of files here. And I'll start from the most basic. So the first the first here is the Docker file itself, which is not surprisingly a requirement of any app to be Dockerized. You put this in the root of the the root of the project, and you pick your base container here. So in this particular case, I'm using the first one from, sorry about that, from Chris Wessel's here, the Tupperware one. I happen to I happen to like this one because it's configurable. You can put I find this to be a little more approachable for people that are new to Docker. You can put a JSON file in the root of your project, and it will read that. That's kind of somewhat uncommon in Docker world. Usually most of the configuration ends up in the Docker stuff, but I think for people who are comfortable with JavaScript and you know, some .file configs in the root of their app, which there are now about 50 of them in every app, should be comfortable with something like this. So this is pretty straightforward. There's not much that needs too much explaining there, but you know, so other optional things you might want to have inside your Docker container when it builds the app for you, you know, like Phantom.js and ImageMagick, you know, so pretty straightforward there. So you would put that in the root of your project. In this particular case, so these are all the defaults. So I didn't put this file in there because I don't need any of these things, and I'm fine with these defaults. So just know that these are the defaults that will happen. It won't install any unnecessary things that this particular app doesn't need. But anyway, you can I certainly recommend hitting up this repo and taking a look here and kind of reading through. It's pretty straightforward to use it. So to use it in this app, it's all I've done two things here. So this is the base image. Pretty obviously from this base image. If I wanted to do anything else inside my Docker container before it is finished building, I would finish writing that out in here. You know, so if any Linux command I could run, you know, in here, and it would run that. It would run that inside the container. So there, I'm going to own the entire thing. So it wouldn't do that, but yeah. So that's the base image setup, and in this particular case, for an app that is pretty bare bones, like the To-Dos app, that is literally all you need. So the only other thing that's from the Tupperware README that points out, which is technically optional, but it is a best practice, is to use a Docker ignore file. And a Docker ignore file works like you would think it would if you're familiar with Git ignore files. So all that means, so you can think of the build that happens inside a container as a production build. So the things you don't need in production are here, are the local build things that happen when you are working in development. And just to be a little more thorough here, again, I alias meteor to M. So if you see that, that's what's going on there. So we'll start this up, and of course make sure that this is actually running, so we can see the end to end here. Okay, To-Dos app up and running as it was originally started. So we're good there. So we'll go back to the repo. So the things that we don't need in the production build are you know, the node modules that get built here, and the build files for the packages, and then of course the local database and all of the other files for the local development build. So it isn't necessarily going to break anything if this stuff isn't there, but you're having to copy these files over to the Docker machine, so you're just saving yourself from pushing an unnecessary amount of files that aren't going to be used anyway. So that's practice there, and you probably won't have to touch this folder this file too many more times once you've set it up the first time. I guess probably a good next step would be quick, brief intro to Docker Compose. Let me pull up the toolbox here. So the Docker toolbox is really where you're gonna get started with installing everything. So pretty straightforward. Mac and Windows install. It's less complicated on Linux because Docker only runs on Linux. So essentially, what this stuff does is set you up with a virtual machine that has Docker on it, and then all of the Docker tools like Docker itself, Docker Compose, Docker Machine for managing servers with Docker on them, and then Kitematic is the UI for the VM that it installs. So this is just kind of a UI over a Docker virtual machine. So you can see here, these are all popular popular containers, and you could click them, and it'll download that container, and it'll launch it on that on the VM. And this actually should be a quick payoff here for the sake of demo. Once that finishes downloading, you should be able to click on that, and you will have Nginx proxying nothing. Of course, well done. So we'll skip that, but it wouldn't have happened if it wasn't a demo. It would have just worked. So back to the Docker toolbox here. One of the things in the Docker toolbox is Docker Compose. And what Docker Compose does is it allows you to use a YAML file and define a collection of containers, Docker containers, that together kind of form a unit, a stack, if you will. And in the case of a Meteor app, of course, you have a separate Mongo instance, and in this example here, we have a Mongo container. So all this does is essentially launch when you use Docker Compose to launch this, it'll use, under the hood, it's using Docker to launch your to-dos container and also your Mongo container, and then link them together. So this link is kind of literally a network link. So it changes the host file inside of the to-dos app container, and you can just put that, the name you defined in the link in the URL of the Mongo URL, and this is actually pointing at will resolve to this container. So if this were that instead, that would resolve to that container. Actually, once you do that. So that's what that is. So it's all a kind of a closed network thing within the same Docker host. So because a Meteor app won't run without being connected to a database, I included this this config in here as a starting point to show you how launching a container looks. So we'll go back into the base of this. Before you can actually launch a Docker container, you have to build it. So in this case, this is all you need to do. If you've put a base image in there that satisfies everything that your app needs, which in this case we have, you do Docker build, and then you tag it with the convention is your Docker account name with the app name, and then a tag. So this might also be something like that. You might tag it by versions as well. But in this case, we're just going to do latest, and then the dot at the end just means the Docker file is in this directory, or build from this directory. So easily the most common command you're going to use with Docker is to build. So what this does when I start this is it reads that base image, and you can see it didn't see a Tupperware JSON, so it's using the defaults as I mentioned before. So it's downloading. So the base image, what it already has in it is it's a Linux box that already has Node installed and all of the dependencies that Meteor needs. specifically Node 0.10.41, and of course it's gonna fail. Let's go ahead and delete all that junk. Yeah, so the base image already has all of the dependencies that that the app needs, and then the only thing it needs at that point is Meteor itself and the app code. So it downloads Meteor and installs Meteor, copies your app code over, and then it does a Meteor build the same way it would if you were to run Meteor build in this same directory. So let's try that one more time. So I just deleted all my cache there, so it'll have to download that stuff again. Just another VM running in case this totally hoses me, because it seems like that might be happening here. I already have this stuff built and pushed. I was really kind of just doing this for demo purposes here. But if we look over here in my Docker Hub account, lots of people like to record screencasts of their demos and then talk over them. Now is one of those times I kind of wish I did that, because looks like the default Docker VM is hanging on me here. So not a huge deal if I can't actually demonstrate this for you, but so once the okay, there we go. We'll do it on this other one. Okay, so try that one more time. Okay, so now it's downloading the base image. Sorry about that. It's downloading the base image, which again has the Linux OS, the base. Which actually, while we're doing that, let's go look and see what's in that base image. If we look inside the Docker file, the Tupperware repo here, you can see that it comes. The base image is from Debbie and Jesse, which is literally the distro and the version, the release. And then there's a couple of environment variables set here. I assume most people that are familiar with Meteor are also familiar with environment variables, and they are the standard way of passing in configuration to Docker containers. So these could all have been on separate lines or all on one line like you did here. Pretty straightforward there. Copy. The copy command is literally copying over the scripts that are, if we go back here, into the includes directory. These are all the scripts that set up the operating system, set up Node, all of those steps. So again, huge advantage of doing this is you have your entire operating system and it's set up completely in version control, and it consistently runs the same way. So not a whole lot else to see here. So the Bootstrap script sets up the whole OS and everything else. And then once you use this base image to start your app, this is the script it does to start up Node and point it at your app. So let's go back and see if that build is done. So we can see here it pulled down the whole base image that we were just looking at. It then copied our app into that container. And now it's running the build script, which is essentially is downloading Meteor, and then it's installing Meteor, and then and then we're building the app, which is literally just the meteor build command with a couple of arguments. So now it's going to install NPM dependencies and anything else that's in there. Pretty minimal for this app because it's just the to-dos example. So the last thing you want to see is successfully built and then a container ID. So now if I did go over to our configuration here, so I can use now I can use Docker Compose to start up that app. This is the same name I named that when I built it. So it'll know to use that. And then this is the standard Mongo, the official Mongo image that comes out. And this is the command it'll run when it starts Mongo up on that server. So starting up the app. So I'm sorry. So because we have this link here and it's linked to Mongo, that also at the same time has a function of declaring a dependency. So when that link is there, Docker Compose knows the app needs to have this running before this starts. So Mongo will download and start up and be ready for connections before the app comes up. So let's see what that looks like. So that's simple as just doing Docker Compose up and D for detached, meaning to not stay in my terminal session. We'll go ahead and do that, and it'll pull down all the layers of the official Mongo container. So kind of again on Docker fundamentals here, the basics of Docker is that it's all, Docker containers are all broken down into layers, and when you change something about a layer, only that layer needs to be transported. So kind of like the operating system analogy from earlier, but it even goes down to a more granular level of every single line on a Docker file, every little command you put in a Docker file creates a new layer. So now if I went and changed one of those lines, it'll only rebuild that one line and it'll use the cache of all the other layers before it. So yes, incredibly efficient for moving parts around. And now if I run multiple copies of Mongo or my app, for instance, from this same server, they will all use the same base image. It won't download a whole other copy of it 100 times over if I ran 100 instances of it. It would be using from the same files, but they would be entirely isolated in their own environments. Okay, so as we can see there, that worked. So let's do the ever handy Docker Compose logs, and that will spit out the logs of our two containers. So it happened to spit out the to-dos logs first, but it's starting your application. That is the expected only log output of that particular base container. So that means the app is running, there's no errors in there. And then this is, of course, all of Mongo's startup logs outputting here. And there are no errors in there as well. So if we back out of there, and I happen to know, well, actually, let's see if I created because Docker's default VM was bailing on me because I was choosing to use it in a demo. I created my own, I created a new VM with Docker machine real quickly and called it local 03, I believe. So I can get the IP of that machine like that. And we'll go over to our browser and there we are. So same app, now inside a container and connected to a Mongo container. So this is a full production build. It's the output of Meteor build and connected to a separate Mongo container. So we can take a look at what we have running here. Do Docker PS for Docker, to show processes, Docker processes that are running. And you can see the two processes that are running on this server are the to-do app we just built and the Mongo container. Now, there are tons of commands you could do to inspect any one of these things. So let's just use this one as an example. So Docker inspect, and then you do the container ID or the name, and you can see all kinds of stuff about this container. It's the environment variables that are passed into it, the exposed ports that you can get into it on. All ports are closed by default, so you have to specify what ports are open. Which, if you remember from our Docker Compose here, I've said I want port 80 on the host to be able to be wired up to port 80 on the container. Excuse me. So when something hits port 80 on the host, like I just did in the browser, it will route that traffic to here. So obviously you can only have one thing on a given server with port 80 exposed publicly. So if you wanted to have multiple instances of this container on this server, your next step would be to have a load balancer container in front of that that would route based on domain name or something like that. In an effort to not get even more dense than it already has, I won't go into that. Wow, I'm really killing it on time here. Sorry. All right, so we now have that running locally. So let's do that one more time. We can see that both our containers are running locally. So, all right, how does this translate to somewhere on the public internet that somebody else can see? So we're going to go to Docker Cloud. I'm not going to walk through too much in the setup here in the interest of saving some time. But this is the default dashboard here, and I'm going to go ahead and terminate the example I had running from earlier. Oh, I'm sorry. So first things first, let's make this publicly available for the automated build. There's nothing. Well, actually. Let's see. Or Docker config. Okay, so that's up on our repo here. Yes, 2 commits. Okay, so by the way, this everything we've done here is going to be available in my GitHub account here at this link. So we'll go back to right. Okay. So I'm sorry. So I built the container. I did the Docker build command. The only thing you would do after that, synonymous to Git push and pull, is Docker push and pull. And I'm now going to push this up to my account on Docker Hub. So that I can actually pull this from anywhere, the same way you would pull your app source from anywhere. Because what's going to be happening is it's going to be pulling from the app servers that it gets deployed on. So I built this container, I've tested it, and made sure it works fine locally, and I pushed this out to Docker Hub, and now I know I can pull this to any Docker server anywhere of any kind, any Docker server that's running Docker, and this container should run in the exact same way. So you should expect to have the same results no matter what, because everything is encapsulated inside that container. And the server itself doesn't care what's actually in it. It'll just expose the ports you said to expose and point traffic at it. And everything else that happens inside the container is completely black box to the server. So while that's pushing to Docker Hub is notoriously a little on the slow side, but to be fair, that was several hundred megabytes there, and I'm also streaming video screencast, so I guess it's not that bad, but it is sometimes if you have a large app, it can be a little bit of a painful push sometimes. So let's go back to so this is Docker Cloud again. So first things first, I've already done this, but for the sake of explanation, you would go into your account settings, and you're going to need to add a cloud provider so that you can have some servers. Pretty straightforward there. So you would add credentials, and it could fill out a handful of things. Pretty self-explanatory. DigitalOcean, because it's about as easy as it gets to use. I went with that one for this demo. But you hit link account, and it'll bring you to a DigitalOcean authentication, and then it redirects you back to this page, and that's it. You don't even have to copy paste API keys. It does it. It does it that way. So dead simple to use there. Once you have those credentials in there, you can now go to nodes and launch a new node cluster. Again, I already did this, so we won't wait for it, but so you would name it something. So I might name it to-dos example, so I remember what's on this server. Deploy tags are optional, but that's how you might, for example, if you had two servers, one for the Mongo containers and one for the app containers, you might, you might put a deploy tag on there of app or a deploy tag of Mongo. And then in your configuration, you would put those deploy tags in there, and that's how it would decide what server to put the containers on. We don't have any tags in our config right now, so we'll leave that empty. But the provider, DigitalOcean, pick a region, and then pick the size. These are all the same sizes that you normally see when you're firing up a server on DigitalOcean. So we'll just pick that one because it's big enough. You could launch up to 10 at a time in a cluster. If you wanted to, and it would treat them all kind of like one logical unit, and it would just, if you were deploying things to anything on the to-dos example cluster, it would, Docker Cloud would just make the decision for you on where to place things. It just kind of automatically takes care of orchestration for you. So then you would hit launch, and it would hit DigitalOcean's API and start launching servers. Once that's done, you get this. Which is just one server. So if I look inside here, I can see the containers I just killed. But so we have a server ready for launching containers. Sorry, I feel like I'm rushing here, but got a little long-winded here. I want to make sure I get all this in here. So kind of the way Docker Cloud works and the way Tutum worked is using what they call stack files. And stack files are basically almost identical to the Docker Compose file that we saw before, with the only difference being there are some additional syntaxes that you can use. For example, auto redeploy is one, and we'll make use of that shortly when they automate the deployment from GitHub. So this is a stack file. This is obviously a little more complicated than the original Docker Compose I showed you before. But this is all basically the same, with the exception of it now has oplog URL, and it has the Mongo URL. This is actually, as much as this doesn't look like it can possibly be a valid Mongo URL, it actually is. This Mongo 1, Mongo 2 are the host names for these down here. As you can see, they're linked to those. So there's Mongo 1 there, and with the configuration for the Mongo primary, and then Mongo 2 and 3. This is the second. Mongo 2 is the secondary, and the third is the arbiter. There's no data on it. It actually just handles replica set. It handles elections when a failure happens when a failure happens in a replica set. If one fails, the arbiter is the one that says this one is the new primary. Lots to read on Mongo replica set. Probably no better place to go than the official Mongo docs. Lots of long-winded explanations on that. So I won't go too far into that. But what this is my my launch doc replica set image that I mentioned earlier. And if you go to this repo, which I will get with Josh and figure out a way to give actual clickable links to everybody here. But this repo has a long description of how to build and push and use the replica set Mongo images that I'm using here. But there is one already published on Docker Hub that you can use. The only caveat being they all have the same key file in them for communicating with each other, and that is not good. They're not in this case, they're not exposed to the public, so it's not a big deal. But if you do end up using this, short version is build your own copy of it. Follow the directions for generating your own key files. It's how the three Mongo instances communicate with each other. You can kind of think of them as like SSH keys for internal communication between the three servers. So again, if you end up using this yourself, just go through the directions from top to bottom and build your own version of it. But for the sake of demo, we're going to use the one that's already published on Docker Hub. So we're going to go back to the create a stack thing. So basically all we have to do is paste in that configuration, and technically that original Docker Compose I had, this would work. If I paste that in there, that'll launch on that server as is. And actually, for the sake of demonstration, let's just do that. So go ahead and just paste that right in there. No replica set. Okay, and then we're just going to, actually, yeah, we'll create and deploy. So it knows it has a dependency on that Mongo container. So let's see, it'll start firing that up. That should come up pretty quick because I've already done this before, so the container should be cached on the machine. And once that Mongo container finishes booting, it will then start launching the to-dos container, which it is going to have to download again because I just pushed another version of it. But while we're waiting there, I can open in a new tab here, or look at the Mongo container itself, and we can click on the logs here, and you can look at the server-side logs, and you see the same thing that we saw when we did that locally earlier. So you can do, all right, so it's already done. So we'll go into the to-do here. We look at the logs there, and we see that same one-line log from earlier. So if we're let me back out here. So this is the stacks page. It shows you all the containers that are in your stack. And we'll go to the app container, and we'll look at endpoints. And this is what you would point your domain name at to get to your app here. So we'll go ahead and open that. And there we are. It's deployed. Is the exact same container image that we just did locally. So that all worked. And again, if I wanted to run 20 of these across 20 other servers, I would basically just put a load balancer in front of them, and everything else would be done the same way. So if this wasn't exposing port 80, I could actually run a bunch of those on the same server right now. Or if I had a server cluster running and I had 10 servers running, I could hit that up to 10, hit apply, and it would launch this container across all 10 servers. And then, of course, I would hopefully have a load balancer in front of that, so traffic gets routed accordingly. But it's that simple to deploy across 10 servers, and we haven't touched a single server configuration at this point. So the last little bit, I know I feel like I'm rushing here. Sorry, guys. So the last little bit to kind of complete the workflow is attaching that particular container to a registry. Or I'm sorry, to your GitHub repo. So you go to the registries tab, and this is of course, that repo that I pushed to before. So I've already set this all up before, but let's see here. All right, so this is already launched. Let me edit. I can get the same dialog. So yes, so when you start a new repo, had I not already done this already, you would get this dialog. Note that it is currently in beta. Not that that ever scared off any Meteor developers. So this is your GitHub org. In this case, my account. In this case, the repository name. It's the same one we pushed to before. Auto test. I encourage you to click the link there and read about what all that is, but that is what it sounds like. It will optionally, when it builds your container for you, it will run tests for you if you want to. Obviously, we didn't write any tests for this app, so there isn't anything to run. But the last part is the tag mappings, and this is the tag that I put on the Docker container itself when I built it locally. This is, of course, my GitHub branch. And then auto build is checked. Now, if I also wanted to have, perhaps a staging tag, I might do something like this. If I actually had a dev branch, and that's funny, it'll actually let me do that. And anytime I push anything to the master branch, it will build a new Docker container with the tag latest, with all of these, all this info. And it'll push it to Docker Hub, which we had over here. You can see my tags here. My latest tag pushed 11 minutes ago. So that's it. So I can hit save and build, and it would build it again. But I've already done that. So we'll do save, and that's that. So now, anytime I go back out here, and I'll change the README. In the interest of saving time. Okay, and go back over here. And I don't know if it'll happen that fast, but yeah, build in master. So it detected, the hook came from GitHub. And if we go in here, it doesn't show it in the UI here, but if we look in the timeline, you can see that it's actually, it's cloning it from GitHub, and it's going to start up, it's actually going to build it on one of my servers, which right now is, I only have one running. So it'll set up the whole build process on there. Essentially everything I just did locally, the local build, and then Docker push and push it up to the repo, to the Docker Hub repo. And then if I have, that brings me back to the stack file configuration. If I have auto redeploy true, when a new version of the container hits Docker Hub, it will auto redeploy this app. So that's optional, and potentially dangerous. Maybe not if it's a staging server, though. But if you have tons of tests running, then there's nothing dangerous about that, right? So the last little bit is to so we can see the no replica set version worked. I'm going to go ahead and terminate that so I can free up port 80 on that server. And then we'll go to create stack and do the same thing with a replica set. And again, this is all in that repo. And you can just copy and paste this whole thing. It's the configuration. Again, it's configuration for the Mongo replica set, and then basically almost the exact same configuration for the app itself. So you can go ahead and copy that and paste it into here. I'm going to just create stack. I'll tell you why in a second. I'm going to go ahead and create stack, which means not start everything. And because sometimes the app can come up before Mongo is ready, we're going to manually start this stuff. So we'll start the first, the secondary and the arbiter and make sure they're up and running, which should only take a few seconds. Hit the primary. That should only take a few more seconds than the other two. The only reason that one takes a little bit longer is because it actually has to configure users and replica set configuration. That's all kind of happening right now. And then I usually give it, maybe 10 seconds or so before I start the app. In this particular case, no, it won't have to download it again. So I'll go ahead and hit start there. While we're waiting for that, we'll go look at the Mongo primary here. And you can see in the logs that are flying by here, I'll back up a little bit to the beginning where it first came up. And the environment variables I passed in my stack file configuration are what was used to configure the replica set. This is all replica set configuration stuff going by here, so it's communicating with the other two containers. Let's back up here and go look at the stack again. And the to-dos app appears to be up. Let's go look at its logs just to make sure. Yep. And go back to the stack. I'm sorry, go back to the app container, get its endpoint, which is again what you would point your domain name at. And there we go. It's a Meteor app pointed at a 3-container Mongo replica set. Again, with the caveats that the data is actually, for the databases, is inside the containers. That is not what you would want to do. You'd want to actually have that exposed and staying on the host, or getting, sitting in a data container. But the essentials, that whole setup is the same no matter what. It was more or less just to demonstrate how you would get it up and running. But persisting data is kind of a whole other talk by itself. So all right. So in recap there, anytime, so now you actually don't need to manage, Docker manually, locally anymore. So you would develop your app like you normally would. You would git commit, git push, and once it hits GitHub, the rest of the stuff, that's it. It's done. So Docker Cloud will then clone your repo. It'll build a new Docker container. It'll push it to Docker Hub, and then it'll deploy it from that image. From the new version on Docker Hub out to your server. So at this point, deploying is as simple as git push, yeah. So sorry, went a little long there, but I was worried I wasn't going to have I was going to have too much time left over. But I feel like I could talk for another hour on any one of these topics on the side here, but. So yeah, I guess why don't we maybe open it up to a couple of questions if there's still time for that.
Yeah. Well, we can record for up to 90 minutes. So.
All right. Am I stopped? Okay, you got it.
Yep. All right. So the first question I actually had is, what's the pricing on Docker Cloud? You and I had a private conversation, but I think it would be interesting to kind of discuss.
Yeah. They do it. They obscure the specific price a little bit. First of all, they obscure the website a little bit here. I have to log out to get to their marketing website. But if you scroll down, cloud.docker.com. And if you scroll down, there is their pricing situation here. So your first server, nodes in this particular case, your first server is free. So what I have running right now is entirely free from the Docker Cloud perspective. Obviously, okay. I'm paying for DigitalOcean right now for that server, which I think the one I fired up is like $20 a month. And I'm also running everything on one, like right now I'm running 3 Mongo containers and an app container on one server. That's not going to be amazing performance. But if I wanted to fire up, to do that exact same setup across 4 servers, the way it should be, the config would be, with the exception of 1 line per item, would be identical. So the config items for Mongo 1, 2, and 3 and app would get a deploy tag on them. So it's literally 1 line in that YAML file that just says tags, and then it's an array of tags. So I might do app for the app one, and then Mongo 1, Mongo 2, Mongo 3, and then I would tag my servers with those same exact tags. And then when I use that YAML file to launch the stack, it would put the containers on the servers that match those tags. And if it doesn't match any, it would fail. So it keeps you from shooting yourself in the foot. But that's how you would do a slightly more complicated setup. But kind of getting off from the actual question being asked here. So 2 cents per server per hour. So what is that? Times day times a month. So $14.40 a month per server managed by Docker Cloud. So not terrible, but, so using my 4 server setup example there that I just said, you're paying for 3 of them, obviously. So it would be, about $45. And that's not counting the server cost. So for those of us that were using Tutum for free for the last 8 or 9 months, it's a little bit of a downgrade in experience because before I could have 20 servers up and it didn't cost me anything. But obviously that was a beta period perk. So not terrible pricing. And for what it saves you from doing, like I said, you could do that entire setup using Docker tools, use Docker Swarm to manage a cluster of servers and just do the entire mess from CLI. But I think for most people, it's worth $14 per server per month to not have to be that guy. Unless you want to be, but I think the majority of people, it just doesn't make business sense because it is not a trivial amount of things that you need to understand to manage all that yourself. The other side of that is what comes with Docker Cloud is there's a whole overlay network, so things can be across cloud providers and it's on its own private encrypted network, and I mean that's huge. So you could run your Mongo instances in different regions, and it operates the same way. Like for those that are familiar with AWS and their virtual private networks, and you could essentially do that except across cloud providers. You could do it within a bunch of DigitalOcean servers, or you could do some DigitalOcean servers and some AWS servers and have them all be on a private overlay network. Right. So there's definitely some non-trivial stuff going on there that would not be easy to pull off yourself. So it's pretty justifiable price if that's something you need to do. Yes, awesome. Yes. The note down there: diversify your cloud. Indeed, that's kind of one of the attractive points of Docker, and before it Tutum was it wasn't locking you into a specific cloud provider. You could use your own account, and you could use multiple accounts. So maybe you have your staging environment somewhere where it's cheaper or whatever. It's pretty flexible.
So now, what are the other options instead of Docker Cloud?
So Docker also has their, it is called Universal Control Platform, and it is is very new, and it is a self-hosted, essentially a self-hosted version of the same thing. I got an early invite to it, and I still haven't gotten around to trying it, but I've watched a handful of videos and read through some docs, and it seems like it's a bit early days, and it's kind of targeted at people who work in an enterprise situation where this stuff will not cross our firewall, and we have to have it inside. So it's anyway, that's one of the first that come to mind. But there's so many I haven't even heard of yet. Every once in a while, I'll stumble on another one. It's like there are no shortage of people in the business of doing Docker orchestration as a service. CodeShip just started started really pushing hard on there. I forget the name of theirs, but there's a whole bunch of them. Some of them are specific to certain parts of the world. There's a couple of European companies that only deal with data centers in Europe, and But for the ones that allow you to use any cloud and your own account, it's a fairly short list, I think. But there are a ton of them for sure. And of course, I was just going to say there's Rancher too, and that's actually kind of been most of my focus in the the last month or so. And for those that aren't familiar, Rancher is essentially an open source version of what you just saw with Docker Cloud. It's self-hosted, so comes with its own sets of responsibility in that department too. So it's free and open source, but you're kind of on your own. Where with Docker Cloud, somebody else is working out how that whole platform works. But it does work well. I've used it quite a bit, and in the process of building more tooling around it for LaunchDoc. Yeah, that's probably one of the next biggest ones out there, but kind of falls into its own category because it's self-hosted and requires a little bit more DevOps background to support it.
So Avaldis asked, how long does it take to redeploy the app with Docker? And is it possible to make it with zero downtime without using a load balancer?
Without a load balancer, no.
Yeah.
No, you essentially are so you would have multiple versions. Obviously, at least two, and then you roll. You basically take it down, put a new version of it in its place. Load balancer switches traffic to there. Now you do a second one, and that's how you do the zero downtime thing with multiple containers. That's one of the ways you do it. But one of the things that comes with Docker Cloud and Tutum and Rancher is a really highly customized, tightly integrated version of HA Proxy specifically for that use. So the whole Docker Cloud and Tutum dashboard, everything is kept up to date real time with WebSockets there, and their entire state of everything in your account is accessible via WebSockets. So their customized version of HA Proxy also has a WebSocket connection to the API for your account. And when you add a new stack for a given app, when you add a new instance for a given app or remove an instance, HA Proxy gets updated real time. It gets that WebSocket message. It's updated, it's configured, refreshing, and it does it, no downtime. So adding and removing containers and scaling up and down, the configuration gets updated near instantly because everything is real time. So yes, the short answer, you can't do it without a load balancer, but implementing a load balancer on any of the platforms I've mentioned is pretty straightforward. It's kind of it's a first-class feature that they've made really easy to use, and it's also how you would use. I kind of ran out of time on SSL setup or description of SSL setup, but that's also where you would terminate SSL. Is in you basically paste a PEM file in an environment variable box and click submit, and that's that. Then it'll serve up SSL certs based on the host name being requested. So you can have any amount of them. So you could have a load balancer with 10 different apps behind it, each with their own SSL cert, and they each just get passed into environment variables. It's a lot more approachable than getting into the server and doing it yourself the way, if you've ever set up SSL manually before. It's way easier than that. It's really just copying and pasting that into a form field and submit, and that is not really the case when you manually set up HA Proxy and 10 apps, all with different domain names. I mean, you're manually editing config files at that point.
All right. I think that was the last question. So thank you, Jeremy.
Because I answered everything.
Nice work.
Yes. Sorry to spread the content so thin there. I wanted to kind of get the whole end-to-end thing, but it's the more details you add to it, the more explanation it requires. So I was trying to fit it all in there so you can, once you get through that whole setup process, and again, you can use that repo as a starting point of seeing the base configs, and you should be able to take those same Docker configs and put them in your own app, and it should work exactly the same way, assuming you don't have any kind of special dependencies, specific to your app. But even then, adding them in there is fairly trivial, and then after that, you don't even have to build the containers yourself anymore. You can just push to GitHub, and it just happens for you, and then optionally deploys too. So
Nice.
it gets a lot easier after that initial hump.
Well, thank you, Jeremy.
Sure, thank you. Glad we were able to fit it in, and thanks again for everybody who took the time to come back out and check it out.
Yeah. All right. Thanks, guys. See you later. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.